Okay, let's give you guys some more practice. So use the ratio test to determine if this series will converge or if it will diverge. So press pause and have a go. Okay, so before we start, if you look at this, if you have a quick glance, this thing here can simplify with this thing here. So if you look at this, n factorial is this n factorial here, and then n plus 2 factorial, that would be this. So when you have one thing divided by another thing, well, if you're trying to understand this, because this is quite tricky to understand. So if you put something simple into here, let's put a 3 into here. 3 factorial will then give you this, and then put a 3 into here. So 3 plus 2, that would be 5. 5 factorial, that will then give you this. So now you can see that this will cancel out with this. And then this here is your n. So this here must be n plus 1. And then this one here must be n plus 2. So when you get this divided by this, all that's left is n plus 1, which is this n plus 1, and then n plus 2, that's this n plus 2 here. So rather than determining if this will converge or if this will diverge, let's try and determine this. Let's work with this rather than this. So now we are, instead of now we're going to perform the ratio test on this one. So with the ratio test, we always need to work out this value here. So with the ratio test, we always need to get the next term divided by the current term, take the absolute. Well, this whole thing here will then become this thing here, because when you put n plus 1 into here, that will then give you this. Put it into here, that will then give you n plus 1 here, and then put it into here, that will then give you n plus 1 here, and so on. Well, this whole thing here becomes this. So now it's just a matter of us tidying this up. So let's try and tidy it up. So visualize this block here as being one block multiplying another block, and then tidy this up. This is really n plus 3. This is really n plus 3. This is really n plus 2. So you can see that n plus 2 here will cancel out with this, and then this one here will cancel out with this. So that will then take you to here. That will then take you to here. So now well, we can drop the absolute sign here, because n is always on the positive side. It's never going to be negative. This is never going to be negative. So we can drop the absolute sign, and then that will then give you this. By now you should be able to tell that as n heads towards infinity, the limit of this, well, the numerator will act as 2n, the denominator will act as n. So the limit is actually 2. The limit is 2. So the limit here is 2. So going back to the original question, we were trying to determine if this will converge or if this will diverge. Rather than working with this, we are going to work with this. So we would perform the ratio test on this. So with the ratio test, we performed the ratio test and it gave us the number 2. So now 2 here is bigger than 1. So this 2 here is bigger than 1. So we know that this is going to diverge, meaning our original series will diverge. Okay, so our original series will diverge. Okay. So next question. So use the ratio test to determine if this will converge or if this will diverge. So press pause and have a go. Okay, so to do this, we need to obtain this value. Get the next term divided by the current term. Well, this whole thing here will then become this. So now it's just a matter of tidying this up. So n is moving from 1 to infinity, meaning that this thing here will never be negative, will never be negative, will never be negative, will never be negative. Therefore, the whole thing will never be negative. So we cannot drop the absolute sign. That will then give us this. So now, hang on. Now let me think. So here you've got one block multiplying another block. Well, visualize this block here as one block multiplying another block. And then let me think. And then this thing here, you can tidy this thing here as n plus 1. And we've done this many times. This thing here is equal to this. So visualize this as this. So now this thing here will cancel out with this. What else? N factorial will cancel out with this. And then actually I should have cancelled this out as well, but it doesn't matter. Okay, that will then so here you can see that here you've got n plus 1 squared, n plus 1 over this n squared. It should cancel out, but I didn't spot it. So blah blah blah. The limit will be 0. Okay, the limit will be 0. So going back to the original question, we were trying to determine if this will converge or if this will diverge. We needed to well, when it comes to the ratio test, we need to work out this value. As it turns out, this value equals 0. Well, 0 is less than 1. So because this 0 is less than 1, then it's saying that the original series will converge. So our original series here will converge. Okay.